All right, everyone, let's begin. So, welcome to this training session on Cisco IP Fundamentals. We are with Anas Ijaz. Anas is our in-house expert on all things networking. Uh, he has extensive experience in the ITSM sector. He's training to become a NetApp certified um, storage administrator. Was it? And a NetApp
It's a data
certified
administrator, yeah.
data administrator, and then a NetApp certified instructor. He's also preparing for CCNA. Um, and so this was a session that we initially planned out to be helpful for people who are planning to do CCNA service provider or CCNA routing and switching at some point in time. Anas will describe the exam that it relates to in detail in this session, and it's for beginners. It's for people who who have intermediate knowledge but they plan to appear in the exam soon and they want to get a refresher on things. So a lot of people signed up for this. We understand that there's beginners, intermediate, advanced users here. Some of this information may be repetitive to you, but it's hopefully it's going to be very helpful when you're sitting in that exam. So that being said, I would like to hand this over to Anas. Anas, take it from here.
All right, thank you, Adisham. Thanks for brief introduction. So yeah, let's begin with the Cisco IP fundamentals. Here we have um, some exams for Cisco side. There are four levels. There entry level, associate, then professional, then uh, then expert, then architect. There are five eventually. So we're gonna go through with that as well. Then we will go through with the Cisco OSI architect. It's not by the Cisco OSI architecture layer, which will be followed by many of the network, which is CompTIA and the other Juniper, the competitor of Cisco, and some other stuff, some other technologies. They all are using OSI layers. Let's begin. As Hatisham, briefly explained, let me go through with my expertise here. I have done my master's in my network from Australia, and done my bachelor's in electronics. Yeah, it's a different thing, but I jumped into the networks field because I was lean towards it when I finished my bachelor's. Yeah, that's why. I went to the system side as well, so I've done MCITP few exams on that. Currently, I'm working as a lab operations specialist and associate instructor. So we are basically, provisioning lab for the NetApp students in the vSphere environment. We have plenty of ESX servers, and we are maintaining those in a vSphere. Our co-location is in Arizona, and I'm managing those servers, provisioning lab for the students. I have also worked on AWS and Azure. Yeah, I've done AWS, you know, creating provisioning machines, spinning up some Linux servers, spinning up some Microsoft servers on AWS as required by the labs for the students. And I rarely work on Azure, but I know how the resources working on the Azure as well. Um, in the network administrator side, I have learned a lot on Office 365. I know how the licensing things work in the Office 365, how Exchange working, how the other, attributes of Office 365 interconnect with each other. So I have worked a lot on Office 365 as well. Before that, I was doing network and system administrating in the same company. So, I was getting my hand dirty on these Cisco's router and the switches. All right. So the course of the course objective would be a Cisco training and certification program, right? And then we're gonna go through with the layers architecture, and then we will touch base on subnetting. We'll discuss about the classes. We discuss about classless subnetting, and then we'll definitely go to the routing world. Although routing itself is a very wide topic, so it is very very hard to cover all the things in a single hour session. So I would say it's kind of a touch base for you guys, and for those who are beginner, that would be that would be really helpful. But for those who are already done their certification, it's not going to be a fruitful for them, but yeah, it's kind of a refresher. So after finishing this, all these slides, I would say we will be well prepared for intro exam. That is 640-821 for, it's a fundamental of IP for the CCNA. So I hope you're gonna go and, hit out that intro exam for the the fundamentals of IP for the CCNA. The agenda of the course, as I told, certification program, OSI Layer Architect, and Layer 3 concept. We're going to touch Layer 3 concept a bit briefly. Then IP addressing fundamentals, and then IP routing fundamentals. All right, guys. So in the Cisco world, we have 5 level of expertise. Number one is entry level. Number second, associate. The other one, after that is professional, then expert, then architect. I wouldn't include architect as a um, in the expertise field, because only if you are in the designing, if you want to go for the designing, then architect offers only that exam. But apart from that, if you go for the routing, switching, wireless, or other industrial program, it's not architect, doesn't help. I mean, architect doesn't offer any exam. All right, so the next slide, which would be a clear depiction of the certification path for the Cisco world. Let me show you that. So here's the thing. So the certification path comes along with different flavors. It's up to your choice which one do you want to opt for, and it's up to you on which path you want to grow your career, right? So the initial step would be the entry level, that is CCENT, right? You're gonna take that exam, and then after your career path would be expand to the other field. That would be data center, routing and switching, collaboration, security, cyber ops, wireless, and let me have a pointer here. So yeah, cyber ops, wireless, service provider, designing, cloud, and industrial. Back in if I would say 10 years back, we don't have this much of wide range of the subject in the Cisco, but now Cisco offers a lot of wide ranges. So the most favorite, and I would say the popular path for Cisco, the most people go with routing and switching and security. So these two are the most favorite for the Cisco path. But before that, you have to do mandatory entry level exam. If you go for the security, if you go for CCNA routing and switching, ICND2 would be your first choice. You can do ICD and ICND one as well, but there is no prerequisite for CCNA ICND2 here, as it's written here. You can go and check the Cisco website. You can find this chart over there. I hope it will be clear more if you go to the description as well. All right, let's move to the next slide. Oh, come on. All right, let's begin with the OSI layer architecture. As definition says, the open system interconnection, which called as OSI, is a conceptual model which is created by International Standard of Organization. So ISO has, provided us this model, and this model is a standard language for the computer system, right? I would definitely say it's a universal language of computer networking. It has 7 layers, which stacked upon the last one. You know, this architecture layer, if you are following CompTIA Network Plus, if you are following other, the Juniper, Huawei, and China comes with the other vendor that is Mampu. You know, this will follow, and you have to follow these architecture. So we have another model that is called TCP/IP. In TCP/IP model, we have the first, I would say, the last three, which is application. We'll follow the top to bottom model. Okay, so I'm gonna go through with application layer first, then last with the physical layer. So in the TCP/IP model, the first 3 layer would become application layer, the fourth one become transport, and we'll merge network and data layer to the network layer and physical layer. So it's going to be 4 layers for the TCP/IP model. Few of them, and maybe in the Cisco exam you'll get to know about TCP/IP as well, model as well. Okay, so let's go through with the others. The next slide. All right, guys, application layer. So as you see in the chart, it is a topmost layer, which is directly interact with the user. It represents the purpose of communicating in the first place of the application layer, and I'd say it's a home of protocols and services that compromise an application. The application that you're using, which would be email application, which could be the web application that you're using for browsing purposes, or whatsoever. So application layer comes there. So this layer also serves as a window for the application services to access the network and for displaying the received information to the user, right? So application layer comes on top, uh, and it will show you what's happening what's happening at the top level. You'll get the data accumulated after going through with bottom to top, right? And it will represent you a human readable thing. Okay, so let's jump over to the next. See, the next thing is presentation layer, right? So, and this layer is primarily responsible for preparing data so that it can be used by application layer. So a presentation layer comes handy with the application layer as well, because it has to prepare data for the application layer, and it make the data presentable for you. So what's happening at the back end, it is basically translating from language to language. That could be ASCII, that could be EBCDI, all right? And it is doing encryption, decryption, right? It is encrypting the thing for sending the communication over the network, and at the receiver end, it would be decrypting the thing to show you as a plain text. So, encryption, you all know about it gives a cipher text when you do encryption, and when you do decryption on the data, it would give you the plain text, right? So one another thing for presentation layer, it is doing compression. So what compression is, basically we don't know how the communication work on the on the network level, right? So it reduces the number of bits and send it over the send it over the network. So it it is the presentation layer duty to compress the data according to the network requirement, right? The most common example would be GIF. It's a photo extension, JPEG extension, ASCII language, and TIFF is also. Mm, I would, I think it's yeah, it's a extension for photograph, right? Or any snap. All right. So after the presentation layer, the session layer comes into the place, and it basically let me tell you what the session is. Session is basically the time when the communication begins and closed. So the time duration between the opening and close of the communication is called session, right? This layer is responsible for opening and closing communication between two devices, right? The application layer duty is to opening and closing the session. It ensures that the session stays open up till the certain time period, right? So the session layer knows how long will the connection will be open, and it also knows the how long will be the session open if that much data requires to be sent over the network, right? Typically, you'll see the protocols such as NetBIOS. NetBIOS means network basic input output system, NFS, and RPC. RPC normally called a remote procedure call, right? So the session layer function is session establishment, right? Maintenance up till the communication happening and the termination. All right, let's move over to the next layer would be transport, right? All right, so guys, transport layer is doing segmentation. So whatever the data comes from the session layer, it is doing segmentation. This layer is responsible for end-to-end communication between two devices, right? And this includes taking data from the session layer and breaking it up into chunks called segments. So whatever the data comes from the application layer, it chunks it up and it makes it as a segment before sending it to the layer 3. It is also responsible for the flow control and error control. So transport layer first receiving data from the session layer, right? And then it breaks up into chunk, then is also responsible for controlling, for flow control and error control. These are the two control which is happening on the layer 4 and the layer 2 as well. But we are discussing about transport layer 4. So the layer 4 flow control is a process of managing the rate of the data transmission, right? So transport layer know that how much data would be transmit over the session, right? So if something happens that, if something bad happens, like the data is not managing, like the other connection has the different bandwidth speed and you have a different bandwidth speed. So it is the duty of flow control to managing the data rate. And the error control is there. So the error control means the transmitted and received data should be the same. So let's suppose if Mr. X sends some data to Mr. Y, so it's the duty of transport layer to track the data whether the X sender has sent all of the data to the Y sender, and the data also, the data which is coming from X is properly received by Mr. Y, right? The protocol is being used in the transport layer is TCP and UDP. So there are two mainly protocols used in the transport layer. The one is TCP and the other is UDP. TCP is basically called as a connection-oriented service, right? It's a connection-oriented protocol. It has a three phase. The one is connection establishment between the two nodes, between the two sender and receiver. And it has, the second phase would be data transfer, and the third phase would be termination, right? In this type of transmission, the receiving device sends acknowledgement. So the main difference between TCP and UDP, that TCP sends acknowledgement and UDP does not. So after the data sent to the received by the receiver, it sends an acknowledgement to the sender that I have received the data. So that is why it is called connection-oriented protocol, right? Rather, on the other hand, UDP is a connectionless service, right? Once the connection is established, the senders send the data without any acknowledgement. It bursts the data out from its end, and it doesn't care about whether receiver received the data or not. It eventually sends all the data, and so that's why it's called connectionless service. Normally, we are using UDP services you know in communication, in the voice communication, and in the YouTubing, or web streaming servers. While on the other hand, TCP has its the messaging services, the email, and the other stuff which is not related to the UDP. All right, guys. So after the transport layer, it cuts down it sends this data to its transport layer, right? So transport layer comes underneath. Oh, sorry, the network layer comes underneath transport layer. Uh, Well, everything happening in the network world, basically in on this layer actually. So what's happening in the router, what's happening in the gateways, it's all about the network layer. And if you see TCP/IP model, network layer also accumulates the switches into it. So all the switching is happening with respect to TCP/IP model. But let's talk about the OSI here. So network layer is responsible for facilitating data transfer between two different networks. It breaks up the segment from the transport layer into smaller units, and this unit called packets. The device, such as router, is used to determine the best path for the packet, and it also known as routing. We'll definitely discuss about more in the future, in the later on slides, because we're gonna discuss about IP routing. We're gonna discuss about IP. We're gonna discuss about IP subnetting. Just a second, sir. All right. So the The network layer works for the transmission of data from one host to another located in the different network, right? It also takes care of packet routing, that is selection of the shortest part, transmission of the packet, and it encapsulate um, the header, and the header contains, it receives a segment from the transport layer, and it encapsulate the header of information that contains sender IP and receiver IP. So after this, it goes to the data link layer, which is also known as switch layer, right? So there are two functions. Let me clear on the network layer. There are two function. Routing is the main function, and logical addressing, I would say, because logical addressing is a unique addressing for the IP addressing, I would say, because this IP unique addressing would differentiate the routers, the devices which are using in the network layer from each other. So uh, logical addressing basically is a key which identifies which router contains which information. All right. So after this, we're gonna go jump onto the next slide, which would be data link. Um, Data link layer is very similar to the network layer. Why? Because it also transfers the data, but it is basically transfer data between intra network. It's not for the internetwork. So that is why we call it a switched network, right? So it facilitates transfer data between the two devices on the same network. The data link layer is also responsible for, as I told you, it is also responsible for flow control and error control, but in the inter-network communication. It's not for the inter-network communication. Switches and bridges are the data layer link devices, such as, there is a separate subject of switching in the CCNA, where it comes lots of stories for for the network guy. I mean, I have learned a lot on the switching as well. There would be STP, there would be VLANs, there would be intra-VLAN routing. So, it is also a wide subject, and we have to have proper understanding on switching as well if we'll be preparing for the CCNA session or exam, or NP exam. So the packet received from the network layer is further divided into the frames. What it does, it is framing, right? The packet which is received from the network is encapsulated with the frame. The frame consists of the MAC address, right? The MAC address is based on the NIC, which is network identification card, right? And the MAC address is basically comes with the vendor which provide the NIC, network identification card. So it encapsulates the sender receiver MAC address in the header, right? Let's go to the physical layer. All right, so physical layer is the bottom layer, or if you are following the bottom top approach, that would be the first layer for OSI architecture, but it would be more convenient if you follow the um, top to bottom format. It's gonna be very handy. So, oh, we are running late. It's already 2:30. All right, 4:30. Sorry. So, let me um, discuss it very quickly. Physical layer is basically responsible for actual physical connection between the devices, right? So it's a connection between the devices. It could be the hardware connection, it could be the, whatever, it might be the fiber, it might be the DSL, whatever it is. It's a connection between two devices. What it does, it will, when data reaches to the physical layer, it converts the data into the bit stream, right? So one and zeros. It does one and zeros to the data, and it sends over the medium. The medium would be whatever it is. It could be a DSL, which is kind of obsolete. It would be fiber connection, or whatever the data medium is using. Ethernet or wireless card is an example for the physical layer, because this is the I would say the gateway for the communication to pass the information, right? There are four things: bit synchronization, bit rate control, physical topologies, and transmission mode. There are four things for physical layer. Bit synchronization does a clocking, right? So this clock control both sender and receiver synchronization level, right? At a bit level, sorry. Bit rate control, the physical layer also defines the transmission rate, that is number of bits sent per second. So it controls the bit rate, which is the number of bits sent per second. The physical topologies, it could be mash, star, you might heard those technologies if you are a network student. There's a mash topology, bus, and star topologies. It controls the transmission mode as well. So, you know, physical layers also define the way in which the data flows between the two connected devices. The various transmission mode, I would say, I would refer this to simplex, half duplex, and full duplex. These are three known transmission mode in which the simplex would say the one-time data send, and half duplex would be like from one end to if one sender is sending data to the other sender, the other wouldn't. And the full duplex means the both communication can be done at the same time. All right, guys. I think we are covered almost all of the layers here, right? So I'm gonna put this in a nutshell of this OSI layer. Let's suppose if something is if someone is doing emailing from the application layer. Oh, why it's not running? Just a moment. All right, yeah. So application layer, if you're composing an email message, it's in front of you, the computer is in front of you, then what you do, you type the email, and then it it crosses to the presentation layer, it goes to the presentation layer, and then presentation layer would definitely see what could be done for the data to be transmitted over the network, because it compresses data, it's encrypt that data for the receiver, and uh, then the data goes into the session layer. The session layer, basically, what I told you, it makes a connection, it makes a session between the two entities, the sender and receiver. This session layer also helping towards the um, it's helping towards the permission and authentication for the connection, and it also does the registration for the network, for the session. The protocol using is RPC NFS, told you. So after the session, the email goes to transport layer, where it segmentize that data frame, and it makes a decision whether um, it could be the connection oriented or connectionless. So if the email comes, it's gonna be a connection oriented service. All right. So the presentation, then session, then you know those segment will be broken up into the packets when it goes to the network layer. And after the network layer, it doesn't do anything to the data frame. It only encapsulate their information as a header, and after encapsulate the segment frame, the segment, it it routed to the next level, which is data link layer. What data link does with the packet, it would encapsulate it further for for putting the information of MAC addresses into that frame, right? Then it goes to the physical layer, and then it routes to the through the bit stream, which is 101010, right? And it goes to the receiving end, and it will do vice versa, right? Then it will go to the physical layer, then data link layer will see which which IP route it will follow. Then it will go to the transport layer. It will see the connection. Then session layer. Sorry, transport layer is it's would see the connection oriented services. Then it makes a session. Then presentation layer, decrypted, and then it goes to application layer. All right. So that's what we what we do in OSI layers. That's what is happening basically in the OSI architecture layer. Now the lesson 2, right? Okay, so I forgot that. People might use the sentences like, I would say it's gonna be a lame, but I have pointed out some least lame, I would say. So the least lame I got is to memorize this OSI layer would be like, all people should try new Domino's pizza. So A belongs to application, then presentation, then session, then T is to transport, then N is to network, D data, and then physical, right? P is for physical. The second lame is I've got from the bottom top approach would be, please do not throw sausage pizza away, right? I'm not okay. All right. Do we have a question here? No. All right. So these are the two least lame which I've got from the which I collected from the internet, and which I have stumbled upon. So these are the two least lame. Uh, I'm not a fan of pizza. Neither I'm not a brand ambassador of Domino's. These are just for the reference. So you might learn and you might memorize this OSI layers with the help of those sentences. All right. So IP addressing, IP addressing, I would say it will be the key concept if you are, indulge in any network activities. So you have to know about subnetting. You have to know about how IP works, and I would say IPv4. If you are not good at IPv4 subnetting, if you don't know how other things working, if you don't know how the decimal binary working in this network session, then I'm really sorry for you guys. You're gonna be face very hard time if you don't know about the IP addressing. So IP is a numeric identifier that is assigned to a device for communicate with the other device on a network. So a network device must have a unique address, which is called IP address, IP logical address, right? To communicate over the network, right? We have two types of IPs. You may have come across with IPv4 and IPv6 with the versus sign, right? Yeah, so the main difference between the IPv4 and IPv6 would be is kind of a address length, right? So it has 32-bit of address length. It means it has 4 octets, right? And IPv6 has 128-bit, which is it's larger enough to be unique, right? Um, we are eventually gonna overwhelm with the IPv4 thing very soon, but I've been hearing this for last 10 years. So we are still using IPv4, right? The address representation of IP4 in the decimal, and on the other hand, IPv6 has the hexadecimal. If you see this FDEC, let me clear you. Decimal is from 0 to 9, and the hexadecimal is 0 to 9. But it comes with A, B, C, D, E, F up till F, right? So address in the hexadecimal would be like this. It has 8 of 16 octets, right? Which is um, you know segregated by the semicolon, and it has segregated by the IP4 segregated by the dots, right? And it has 4 octets. and 8 represent binary. So this third point is it supports manual and DHCP address configuration. There are two type of configuration in IPv4. The manual, you can hit manually by going into each device, or you can make a DHCP controller, right? And that controller would give IPs to the devices automatically. So IPv6 doesn't need that. It is also unique, so it supports auto and renumbering address configuration. IPv4 and IPv6, the main the reason behind this would be the one reason behind this would be, the overwhelming of address. We're gonna end up with IPv4. The second thing would definitely be security. So IPv6 has IPsec built-in security feature, but on the in the contrary, IPv4 doesn't have it. Let's talk about the types of addressing in the IPv4. We're gonna discuss about IPv4 here, right? I'll touch base upon the classes, and I'll touch base upon the on the classless addressing. So there are two type of addressing. The number one is the classful address, right? And number two is the classless. So classful address has it's been defined by IETF, the International Engineering Task Force, right? And it has it has you can say distribute the IP networks into three classes, which is A, B, C, and IP range would be 1 to 126 here for the A class, and the default subnet mask would be 255.0.0.0. So, and B class has 128 till 191, and C class has 192 till 223. We also have E and we see D and E, right? For for uh, for the remaining part of the IP range, but D is used for basically for multicasting in the classful address, and E is reserved for military purposes, right? So uh, back in 1980s or late 1980s, it was launched, this class range, but still in still Windows still identify it as a, if you are going to put IP in a window, MAC address, I'm saying, in the network card, if you are going to put the IP, it still detects the classful address. So it depends on you whether you want a number of networks or whether you want a number of hosts. If you want a host to be increased, then you have to have A. If you want B, then it's kind of the network number increases and the host number decreases. Similar goes to C. So if we need a larger network, or big networks, or not a big network, sorry, or number of networks, we have a variety of networks, then we have to go with C, and it's going to have 254 hosts per network, right? uh, that is classful address. So classful address normally uses RIP version. We're going to discuss later, but I'm giving you an example. So classful address in the RIP session, what it does, it automatically detects the range. It doesn't need the default subnet mask. How? So from if we put a IP range between 1 up till 126, it will say, it doesn't need the default subnet mask. It knows the range. It's a class A, so it takes the range as a default one. So we don't need to give the default subnet mask. So that is basically classful address. We don't need to give default subnet masks for this. If the routing protocol support the classful address, it's gonna take the it's gonna assume that default subnet mask will be 255 or 255.255 or the other one. So to reduce the number, to reduce the wastage of IP address, because in the classful address we categorize three and A, B, C, but we see that we are wasting the IPs, right? We are wasting a lot of IPs when we are distributing, when we are categorizing, or when we're giving that block, that whole block, right? So we use subnetting. What we do is that we use host ID bits as a net ID bits of the classful IP address, and we get the IP address and define number of bit for the mask along with it. So what we do, let's suppose this one is a class C address, right? But we do a subnet here. This is called, this slash 28 called CIDR, right? So what it does, it will refer you or refer the device that the subnet mask of the device is not the class C one, which is by default 255.245.245.0, but it should be, if it's 28, I would say it's 240. No, yeah, it's 240, right? So it's 240. So 192.168.1.1 would be the subnet mask of 255.255.255. Let me write it down here. Pen. So the subnet mask would be 255.255. I'm not good at writing, sorry. 255.0. So far, so good, guys. Any questions at the Sham? Are we good, or we have any questions?
No, we don't have any questions.
All right, all right. It's Kazim, right?
Yep.
All right. So yeah, not zero. I'm really sorry. It's not the zero. So this 28 refers to 240. So that is why we are using classful addressing, because we don't want to waste the IP addresses. We have to use those IPs to be utilized in the next. Or you can say in the next range. This gonna be, I would say a big relief for those who's providing the IP, such as uh, internet ISP providers, and they have been given with the blocks and the IP. ISP give you these kind of CIDRs for the network, such as 10, 102.4.3.7 or 8 with the slash of 29 something. So they give you, the IP. I'm really sorry for that. The 28 is actually two. Oh, that was 29. All right. So yeah, 29 is 248.248 of subnet mask at the end. All right, guys. So it's gonna be 25, 255, 255, 255.248 at the end. So let's talk about the IP addressing fundamentals here, or the more how to convert the binary. Um, these are the values. The as I told you, it's in the octet. It has 8 bits, right? From this count, 1, 2, 3, 4, 5, 6, 7, 8, right? And from left to right, we're gonna power 0 with to the power 0, to the power 1, 2, 3, 4, 5, 6, 7, right? The bit value position would be 0, 1, 2, 3, 4, 5, 6, 7. So 2 to the power 7 becomes 128. 2 to the power 6 becomes 64. Then further on, 2 to the power 0 becomes 1, right? um, how to convert this 192 in binary. So we start turning on the bit here. So 192 must have this on, right? 128 and 64. So these two bits are on if we meet this requirement. So when we convert this decimal into binary, these two bits are must be on to to evaluate this 192. Same goes with 168, right? So we need 128 here. We need after that 32, right? So 60, and then this bit, right? So this bit on, this bit on, this bit on. See, 1, 2, 3. Others are zeros. So that's how the binary and decimal conversion work. Most of the exam in CCNA would definitely ask you some kind of question, right? That the what is the subnet mask, and what would be the IP range for this network if we have this address, if we have /29, if they would say, they would give you /29, and what would be the subnet mask, and how many hosts would be in this network, how many subnet, how many networks if we go with this subnet. So that's kind of a question come in a CCNA exam. So this might be very helpful for you guys if you make this chart and in your exam, or you have to know how decimal and binary works. So that is all about IP addressing here. We are running out of time. I'm going to cover the last lecture. Otherwise we will be going through with some question as well. All right, routing. So IP routing is an umbrella, sorry, it's not it's an umbrella term for the set of protocols that determine the path that data flows in order to travel across the multiple network from its source to destination. So what routing does, it select the best path from one network to the one network, I mean the sender network to the receiver network. uh, it might comes a lot of hops in between them, so it is the duty for the router to check it's stable, or to check whether it's statically defined in the router, that which packet needs to be sent on to which router, and which would be the best path for for the packet to be sent over. So data is routed from its source to destination through series of router, as I told you, and it can be done on the multiple networks as well. Let's jump to the next slide. I'm gonna cover. There are two types of routing: static and dynamic. Both has different different, you can say, advantages and disadvantages, pros and cons for both. Statically is I would say for the small networks, or maybe I would say 3 4 routers if you're using in a network, or you wanna go with the and you know that the other network is not going to be disconnected, or the network would be say, let's say, it's not going to be work um if it would be the disconnection, if it would be it's not going to be impact your business, right? So it's a statically defined route on a router which has manually feed by the administrator, right? You need to put manually before start the routing. Static routing is considered the simplest form of the routing. How to put the static route in a router? You are in a global mode, right? You put the route which needs to be advertised, the subnet mask of the route, and the next hop. I would give you a more good example on the next slide. All right, so you see this network here. It has 3 router, right? And each of them are connected with the connection which is serial. The serial one is using, this network is with .1. This network is with .2, right? This network is with .3. This network is with .4. So there are 4 networks here and 3 routers. So how are we going to put the static routing? So when we are defining interface addresses, right? So this is called a fast Ethernet, and this is called a serial one. This one, and this one is called fast Ethernet. We put the 2 addresses, 192.168.1.1 and 192.168.2.3 here. So how to advertise the route? You know, we already defined those connection, which is 1.1 and 2.3 already here. When we are assigning those address, it automatically defines its route as well. So we do not need to advertise those route, but we need to advertise the other routes on the R1, which is 3.0 and which is 4.0. So we advertise the route with the help of IP route command, right? 192.168.3.0 and 192.168.4.0 with the subnet mask. Subnet mask would be /24/24. If you convert this 24, so it means, all the 8 bits on, all the 8 bits are on, all the 8 bits are on, and rest of them are zeros. So there are 8 threes at 24, right? So it's going to be 24 is 25, 25, 25, and zeros. If the all bits are on, it's going to be 25, 255, sorry. So the advertised route and the next hop, right? So for the 3.0 network, the next hop would be 2.4. So we put the next hop here. Similarly, with the other route, we cannot communicate with this computer until unless we have a route of 4.0 network. So we put the 4.0 network as well, right? After putting this address, this is not enough. We need, if we are doing static routing, then we need to have this router to be statically defined and this router as well. So we need configuration of router 2 here. Oh, it's only 3 minutes left. Oh, we're gonna take 2-3 minutes or 5 minutes of your time. I'm really apologize for this description delay. Anyways, let's continue. On router 2, we need to define, the address which needs to be advertised, which would be this network and which would be this network, because we already define this and this. We already define, because when we putting the IPs on the interfaces, it automatically converts those IP to the IP route and it feeds into it. So we don't need to advertise those, but we need to advertise this 1.0 and 4.0. See, 1.0, 4.0. So the next hop would be 2.3 here, and there would be, what is that, 4.3? No, 3.3 here and 2.3 here. All right, so this would be the next hop for this router, right? Similarly, on the router 3, if we need the communication between uh, A to B and B to A, host A to B and B to A. So we need to put the R3 as well. So R3 has, already predefined interfaces, that is 4.1, 4.0 network here already defined, and 3.0 network already defined. So we need to define this network, 1.0, 1.0, sorry, 1.0, and we need to define 4.0 as well into this, right? So the next hop would be 3.4. This is a router 3 configuration. So that's all for the static routing. If you this is how it works when you statically define the routing into the router. All right, guys. Let's talk about the dynamic routing. We are running out of time here. Let me wrap this up very quickly. Dynamic routing is when you are not entrusted to do it statically, you have the power of dynamic routing. Dynamic routing, it used to facilitate the exchange of routing information between the routers. So it automatically exchange. You don't need to put in every router. You just enable that, that protocol which you want to use upon their statistics, like upon their matrices. So every protocol has different matrices. We're going to discuss it. Routing protocols allow routers to dynamically learn information about the remote networks and automatically add this information to their own routing tables. So what dynamic routing does: discovering the remote networks, maintaining the routing information, right? The best path. This is the main key. The best path, right? This is the main key. You need to choose the best path before sending the before sending the packet to the destination network. Having the ability to find the new best path if the current path is no longer available. So in the static, we don't have this option, because it if a path is down, you cannot do anything until unless you fix that path. But in the dynamic routing, it chooses by itself. You give the power to the router that, all right, you do your choice. I have configured the protocol. So protocols that uses are RIP, OSPF, IGRP, ISIS. So we're going to discuss about distance vector here and link state. So there are two types of protocol, that is interior gateway protocols and exterior gateway protocols. So interior gateway protocol contains RIP, IGRP, EIGRP, which was discussed in the previous slide. And in the IGP, we have two options: the distance vector and the link state. So the distance vector protocol requires the router inform to its neighbor topology changes periodically. So whether you have any information or not, they give a periodic updates to its neighbors. And so let me clear. RIP using distance vector protocols. Distance vector is used by RIP. So RIP is updating its neighbor in 30 seconds, or maybe in 40. It depends on you how you set the timer. So it gives update of their information, what the best path it has, upon the basic algorithm was using in the distance vector is Bellman-Ford. We're not going to discuss this because it's itself another topic. So the algorithm which was used is Bellman-Ford, and each router maintains a distance vector table containing all possible destination node. RIP and EIGRP is example for the distance vector. What is the link state? Now, on the other hand, contrast of the distance vector, link state, it's a protocol which gives a complete view, a topology of the network by gathering information from all the other route, right? It uses Dijkstra. It's really hard to pronounce, I'm telling you. It's Dijkstra algorithm, and OSPF is an example for the for the link state protocol. So link state routing protocol requires router to periodically send routing updates, right, to their neighboring routers. And in addition to my, to link state routing protocol are quickly converge. So what is converge? Converge is a point on a link state where, I would say, a routing domain or autonomy system, right? So if you're using OSPF in a system where we have a number of routers, so number of router exchange their in topology view, the complete view to each of them, right? each of the routers. So when every router has done with the information sent and they know that they have sent their updated information, so the point where everyone is satisfied in the autonomous system or a routing domain, it knows as a convergence point. Okay, so convergence is a point where link state routing protocol doesn't need any more power or more CPU usage or more power from your router. But when it comes to convergence, I mean, when it's doing converging and taking the view or combining the topology for the link state, it takes a lot. So it's up to you whether you want to use distance vector or link state in your network. It's up to the need. I mean, if you are having a big network, I would recommend to choose the link state one. If you are going with the distance vector, I would say, you know, RIP or EIGRP, you can use this protocol. RIP has two versions, version 1 and version 2. We'll discuss in the next slide. We are going to discuss RIP and OSPF for each of the example. Let me clear you interior and exterior protocols here. So interior gateway protocol are using in the intra-network domain, and the exterior gateway protocol are using by inter-network services. So most of the ISPs are using exterior gateway protocol, and the main example is BGP for the exterior gateway protocol. Most of the ISPs are using, to advertise their route to the other ISPs. Let's go to the next slide. All right, so distance vector protocol, the RIP, is, as I told you, it's a dynamic routing protocol which use routing metric to find the best path between the source and destination. That's a basic for the routing. It depends upon the hop count. Hop count is basically refers here to the router. So it depends on the hop count and the timer. That if you send a hello packet to the other router, how long will it gonna take to receive the acknowledgement? So based on that, they collect the information and update it to the other router as well, and sends the packet. All right, so the next one would be, there are two versions, RIP version 1 and RIP version 2. The main difference and the overcome of RIP version 1 is 2, because RIP version 1 using classful routing. So classful routing, as we have discussed, it doesn't, we are overwhelming with IPs, and we are we don't want to use we don't waste IP, so that's why RIP version 1 is obsolete now. You can use RIP version 2. So RIP version 2 is used classless, so you can configure both version 1 and 2 as well in the router by putting this command router RIP, right? uh, Router 1, by going into the global config mode, you can put the network here, and then how it gets completed. So that's how easy it is, see, with the static and the dynamic one. So let's talk about OSPF. OSPF itself a very wide topic, I would say, and if you are attempting for CCNA and NA or NP, this could be a lifesaver topic for you if you are in the routing chapter. So the acronym is for Open Shortest Path First. Is a link state routing protocol which is used to find the best between the source and the destination router using its own shortest path first. It is a protocol which aims at moving the packet within a large autonomous system or a routing domain. So that's what we told you when we are referring to the link state. Link state commonly used in a large routing domain, right? So routing domain and autonomous system is a system where you put um, where you enclose the router, right? And it becomes a system, and it you can relate those systems to other as well, because you have one autonomous system, and you are connecting to the internet, so that's going to be the second autonomous system. So your network would become an autonomous system. So how OSP works? So this is kind of an election process in your system, right? If you have 5, 6, or maybe 15, 16 routers, the election happens for DR and BDR. What DR and BDR? DR is the designated router, and BDR is backup, right? BDR is backup. So the election comes into the place, and it depends on the router ID which one becomes the DR router for that autonomous system, right? And after the DR selected, then it comes to the BDR thing. It it will select the BDR. So it depends upon your our router ID. It is the highest active IP address present on the router ID is. And the first highest loopback address is considered. If no loopback is configured, then highest active IP address on the interface of the router is considered. So that's how DR and BDR works. There is another thing which is router priority, and router priority is a 8-bit value. It's assigned to a router which is operating OSPF, and basically it used to elect DR and BDR in the broadcast network. Um, so what DR does, every router in that autonomous system, it sends the update to the DR that I have this information. You take this and you send it to all, right? So that's what DR is doing behind the OSPF, right? So and backup designated router works when the path of the DR has been disconnected and the router cannot find the path for the DR. So then BDR comes into the power and take the information and send it to the other ones. So that's how OSPF works. But um, it is the more complex than the RIP and EIGRP. If you are up towards OSPF, first you have to have understanding of distance vector, then you go for the link state, right? So because I have learned the Dijkstra algorithm, it is quite complex. You need to have proper understanding of the routing of Bellman Ford as well. So that's all from my side. I'm really sorry. I have I've taken 12 more minutes of you guys. Any questions arises in your mind? Um, Anything we have? I think we are good.
All right. Thank you, Anas, for the highly detailed and educational session.
You're
And
welcome.
let's do something that follows next after IP fundamentals.
Yeah, you're right. So let's discuss it with the team, and we're gonna have the other session with some maybe some switching this time,
Yeah,
or
something like that next month. Okay. Thank you, everyone, for attending. We'll see you in our next training session. Bye.
thank you guys. Thanks a lot for your time. Bye.